All right, so this set had a bit of a mix of all different types, and we're just evaluating the limit for each situation. So let's take a look at this first function. We have the limit as x goes to infinity. So since I'm going to infinity, I can get rid of everything except for my leading terms. So I now have the limit as x goes to infinity of negative x over x squared. I'm now going to simplify this down to just an x, and this is a negative 1. So notice my degree in the denominator is significantly larger. I have the limit as x goes to infinity of negative 1 over x, so that's just going to be 0. For this next one, I'm going to break it up into 2. So I have the limit as x goes to infinity of sine of 1 over x, subtract, and I'm going to get rid of this because I don't need it, the limit as x goes to infinity of 6x squared over 3x squared. So let's start with our sine function. We have 1 over an insanely large number, that's 0. So this evaluates to be the sine of 0 degrees or 0 radians. Subtract the limit as x goes to infinity, so I'm going to get rid of these two. I have 6 divided by 3, which is 2. And again, I could cancel those out because of the same, so they're getting large at the same rate. The sine of 0 is 0. Subtract 2, which equals negative 2. Next up, we have 5 times cosine of 1 over x. So again, 1 over x means that I really have the cosine of 0. So this is equal to 5 times the cosine of 0 radians. The cosine of 0 is 1. 5 times 1 is 5. Next up, I have a 4 to the x and an x to the 7. So we have to think back to that original chart. Just as a reminder, our exponential functions, so when we have a base of a other than that's greater than 1, those are always going to get larger at a faster rate than our polynomial functions. So my denominator here is getting larger at a much faster rate than x to the 7th. As a result, this is going to like a billion, and this is like 1. So we have 1 over a billion, so that's approaching 0. So we have 0 subtract 5, which equals a negative 5. Let's look at the next set. We'll see if I can squeeze them in here. So we have x is approaching infinity. So again, when I have something like this, I like to rewrite it as a rational, as a rational function as a fraction, 1 over 3 to the x. So I see that this denominator is getting ridiculously large. So this, I say, is going to 0. So this equals 0 plus 2, which is 0. Which is 2. Right here, we looked at a similar situation in the last problem. We had 5x cosine x. This cosine x is oscillating between negative 1 and 1. This is going to negative infinity. We can't pinpoint that's approaching, so it does not exist. This is the exact same situation, does not exist. Over here, I'm going to cancel out all of these terms because they're just extra. And always make sure that your leading coefficient is written first, because sometimes it may not be. So you do want to make sure that those values you're canceling out are not your leading coefficients. So now I'm analyzing the limit as x goes to positive infinity of 9x to the 4th over x to the 7th. This cancels out. This is left cubed. This number is significantly larger, so I get 0. Down here, I'm going to cancel these guys out. I have 3x squared over x squared. Well, these guys are the exact same. So I really just have the limit as x goes to negative infinity of 3, because these are getting larger at the exact same rate, and we get 3 out. All right, let's take a look at this one. We have cosine of 2x subtract pi x squared all over x squared. So I can get rid of this, right, because that's not a leading coefficient. I have pi x squared over x squared. These are my leading coefficients. They match, so I can get rid of those. They're going to cancel because they're getting large at the same rate. So I'm really here just taking cosine of pi, and cosine of pi equals negative 1. All right, from our previous examples, we saw that the limit as x goes to infinity of sine of x over x was going to be 0, because this was oscillating between negative 1 and 1. And this was getting to be a really, really large number. And so we have 1 divided by a really, really large number, which gives us 0. We're subtracting 4 from that, so we end up with 0 subtract 4, which is -4. All right, x is going to positive infinity. These ones will cancel out. I have the limit as x goes to positive infinity. I have negative x to the fourth over 5x to the fourth. So that's, these guys cancel. That's like the same thing as having the limit as x goes to infinity of a -1/5, which is going to give me -1/5. Over here, my non-leading terms cancel out. I'm left with the limit as x goes to positive infinity of x cubed over x squared. That's going to cancel to just be a positive x, so that's going to go to positive infinity. All right, here I'm going to rewrite this with a positive exponent. So I have the limit as x goes to infinity of x squared over 2 to the x. Now we need to think about which one gets larger at a faster rate. So the exponentials that have a base of 2 are going to get larger at a faster rate than x squared. This is just infinity times infinity. This one would end up being really infinity to the infinity power. So we end up with 1 over a ridiculously large number, and so we have 0. This one's going to follow similarly. Notice though, this is e to the 7th. That's just a concrete number. That's not even getting larger at any rate. That's, I mean, when you're talking about infinity, that's basically equivalent to 1. So this guy's going to be 0 because this one's going to get larger at a much faster rate. And then lastly, we have, so here's one of those mix-up problems, right? You go to eliminate all these, but you see that this is an x to the 7th, and this is a 3x squared. So I'm actually eliminating this 3x squared and this 6, and this -15x to the 4th. So I have the limit as x goes to negative infinity of -5x to the 7th over x to the 7th. These guys are going to cancel because even if we were to put a negative in, a negative divided by a negative is a positive, but then we're multiplying by this other negative. So these guys cancel. I'm left with a -5. And again, these guys cancel because they're the same, first of all, and because they're getting large at the exact same rate.